about these conditions that you are given here. If they tell you, before we now do the second, if they tell you that y0 is equal to 0, it means when x is 0, y is 0. Because the value in here is for x, okay? Because isn't y is a function of x, isn't it? So the value in here is, so if they say y0 is equal to 0, this is the value for x. So when x is 0, y would be, here is the value for y would be 0, okay? Then if they say y prime of 0 is also 0, it means this is the value for x. When x is 0, y prime is also 0, okay? So you'd be writing to say, okay, for this one, you'd say let x be equal to 0 and y be equal to 0, because y is 0 and x is 0, right? For here, you'd now say let x be equal to 0 and y prime be equal to 0. But remember, you'd have found the y prime first. Are we together? Now let's go for deeper, fun, more things. Let's do this one, which is actually not equal. Remember, for the one we solved, we changed the conditions a little bit, right? And we let y prime be 3, okay, when x was 0. So we could have said that y prime of 0 is equal to 3. It means that y prime is 3 when x is 0. You understand? Good. Now let's go and let's do this one that is actually given, where it is not equal to 0. It is not equal to 0. You have the second derivative, but then it is something which is equal to some function. So let's write what we have been given here. We have been given, class, if you zoom in, we have been given that the second derivative, okay, plus 3 times the first derivative plus 2y is equal to 2x plus 3e to the 2x plus 2 cos of 2x. This is what we've been given. So now we are continuing with this. Right, we have been given. Once you have it like this, this is now the one where we are going to say the only way you are going to find y is to do two things. You find u, then you find v, okay? And u is going to be called the complementary function, then v is going to be called the particular integral. So you'll be saying, for me to get y, I need the complementary function plus the particular integral. And you find them two different ways. Let's quickly go for it and let's see how easy it is, because the complementary function is just found by you doing this one, which we did. You solve as if you are solving a homogeneous. But now what you'll be doing is, instead of saying outside thing is y, you'd be saying the outside thing is u, and then you'd be finding the u. So when you get here, what we ended up getting y as this should have been your u. So you do the exact same process but for u. So you would take all this thing which is on the left hand side, and you'd say d squared plus 3d plus 2, outside you put u, is equal to 0. This is the first one you solve. It's not, the outside is no longer y, the outside is u, and it will be equal to 0. Then you go all the way. This is going to be our complementary function. We go out and we solve it. How are we going to solve it? When it's equal to 0, what do you have here? This is the d operator form, right? From the d operator form, what do you create? Auxiliary equations, right? So you're going to change these d's to be m, and we won't go through that whole process. We've come from it. If you've forgotten, go back and watch. So you'd say this is equal to 0 because u cannot be 0. Then you're going to do all that thing, find your solutions for m, and they're going to, your solutions for m will tell you what type of equation u is going to be. It's no longer y, right? U is the one that will have those three cases. If your m is two distinct real numbers, then you say u is a e to the m1x plus b e to the m2x. That means if you get m as two numbers that are different and that are real. If you get the same number twice when you solve u, which is when you solve for m, which is just a quadratic equation, which you are going to solve by quadratic formula to always be safe, then you're going to have, if you get the same solution twice, then you write it to say u is going to be in this form: ax plus b, outside you say e to the mx. And you would have found your m, you come and you replace here. Then you would then find the a and b using the what? You would then find the a and b using the solutions. Then lastly, you would say, okay, what if I get complex solutions where I have m being equal to alpha plus or minus beta I. Okay, so in other words, you get two solutions for m: alpha plus beta I, and then the other one is alpha minus beta I. So your m1 is like alpha plus beta I, then your m2 is equal to alpha minus beta I. You see? So now we have them, m1 and m2. What you would then do is, for complex solutions, this is now the case when you have complex solutions. This is one when you have two different real solutions. Two, you have the same solution but it's real. Then three, you have two different complex solutions. Then your u now is no longer y. Remember, for we get two different things. We get u then v. Okay, u is for this homogeneous. You now say this is going to be equal to what? E to the real number alpha x. Then you open bracket, you say cos beta plus what? You have your cos beta plus your sine. But for cos beta, you should put the a, always leave. So it is a cos beta plus b sine beta. And then you'd find your a and your b using the conditions, initial conditions. They'll tell you, you go to your initial conditions. We'll see how we're going to do it, but we'll just use our initial conditions, right, to then find how the missing terms in this particular situation. Now what I want you to know is that when you get your u, do not look for a and b yet, because you're going to combine u and v in the last step. Then you look for a and b, okay, when you write y being u plus v. Now in this situation, in this question you have been given, we are going to use this to get our u, and these solutions, the solutions you'd get are the solutions for u. So we're going to use this one, right, because we got our u, we got our m being two different things. So we would use this and stop. We're done. We have the u. So once you have the u in this state, because we found it, we would say, okay, my m is, we found already to be, it's a negative b plus or minus the square root of b squared minus 4ac all over 2a. And we got our m being equal to negative b, which is negative 3 plus or minus the square root of 1 all over 2. That's what we got, because our b squared minus 4ac was 1. And we got our m being equal to negative 3 plus root 1 is just 1 all over 2, and that was our m1. Then we got m2 being negative 3 minus 1 all over 2. So here we got our m1 being equal to negative 1, and we got our m2 being equal to negative 2. So we got m1 and m2, negative 1 and negative 2. So that once we have them, you're going to then say that means u is going to be, there are two different distinct real solutions, right? Distinct is different. ae to the m1x plus be to the m2x, which you say your u is going to be ae to the negative x plus be to the negative 2x. And we are done. This is our u. Now when I have the u, so this is my u, I have my u. Am I going to stop here? No. Now I'm going to find v. Let's talk about how we find v. Nice and simple. So how we find v is we are going to be using the table. We are going to be using the table, which will be provided to you. Let me take you to that table right now. So now look at what it is. I'm going to go to this table. Here is the table, is how you now get your particular integral. Are you seeing? You better see. So here's the situation. I'm going to show you the situation which comes. This is the 2023 paper which I'm using to see. So the particular integral just tells you what you make v. So what you're going to do before you come to this, this is going to tell you what you are going to put as v. But before you come to this, you are going to have your equation. Let me go back to it. We are going to write, we have our u now, we are done. But we are going to rewrite this equation of ours, and we are now doing this. This is what it says. You'll be now saying, look at what you say. You take this same thing. Isn't we know for u, we just looked at this and we made it equal to 0. For v, you are going to take this same thing, but you are now going to make the v be equal to here, f of x, because they say the f of x is the v. So in other words, you're going to say d2 plus 3d plus 2, and then outside you are now going to put v. Okay, because here we have the second derivative plus 3d plus everything, right? Outside you are now going to put v. Then you make it equal to whatever is on this other side. What is on this other side? There is 2x plus what? Plus 3e to the 2x plus what? Plus 2 cos 2x. Okay? plus 2 cos 2x. Let's put it plus 2 cos 2x. So this thing is the v. In other words, now we are going on to then go to our table. So our table would now, we are going to replace this v with something, and the something we are putting in place of v will be from the table, and the table will tell you what to put in place of v depending on what you have on this other side. So on this other side, what do I have right now? I have a polynomial plus an exponential plus a trig. Now, the first three situations in your table are when you have, number one, a constant only, number two, a polynomial only, number three, an exponential only, and let's say the first four, number four, a trig only. Then there are like 6 things. Then you do number 5 where there is a sum, and number 6 when you are multiplying. Let's go and I show you what I mean. Look here. They are saying you're going to replace v and put k if the other side is just a number. So if it was equal to, let's say, 9, but that's not what it was. It had an x squared, it had an e to the x, it had a cos something x, isn't it? That's the situation we had. There was a cos something x. So okay, when I have a constant, I make my v be k, or I make my v be kx. When do I make my bvkx? It is when I have a constant on the other side, but then when I was finding my u is the cumulative, is the complementary function. When I was finding my u, I found one of them being a value. You know how u can be equal to a e to the m1x plus b e to the m2x, right? So let's say or let's say m1 was 0 or m2 was 0. That means that you would then just get a plus b e to the m2x, isn't it? So that means you'll be having a constant. Instead of putting k for v, you now put it as kx. So when you have a number on the other side, let's say you have blah 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 dy squared plus whatever being equal to 9, either v is going to be k or v is going to be kx, depending on your complementary function. Okay, then when you have the other side being a polynomial only, then what is going to be your v? A plus bx plus cx squared. That is, if the polynomial was ending at x squared, then your v will be ending at x squared as well. Then you then look for the a, b, and the c. Do you understand? What about if it was an exponential function? If it was an exponential function of this form, then your v will just be of this. You just put v to say k e to the ax. You understand? What about if I have, we're going to talk about it. What about if I have it being a sine, a trig thing, sine or cosine function, okay? I.e. you have it as a sine px, then you would now have another constant called big A sine px. If it was b cos px, you would then have your v be a bigger one called b cos px. Okay? So here, since they were both there, your v will have them both. Do you understand? Do you understand? Okay, now let's do this one, last one. What do you now do when you have a sum? So you can see that in this first situation is when there is a number on the other side. That's constant, right? This second situation is when you have a polynomial on the other side. This third situation is when I have an exponential on the other side. Then this situation is when I have a trig on the other side, isn't it? Then these last two are for combinations, which is what we have. We have a combination. We have a polynomial, which is something with an x squared, with an x and x squared, right? Then we have an exponential, then we have a trig. So that means we are going to be combining, because that's what you can see here. They say when you have them adding or subtracting, your v will be the combination of all that. So you had here a polynomial. My v will have the polynomial. Okay? And then you had the trig. My v will also have the trig. Then here you have a number, a constant, so your v will have for both. Here you have 2 minus x, which is like a polynomial, so here we would have for the polynomial. Then here you have e to the 3x, it will now be also c e to the 3x. So it's like you put them both. So what did we have? We had all three. We had a polynomial, an exponential, and a trig. So we are going to let our v be what from this table? Let's choose now. All right, so what I just want you to see, let me tell you, if you look at all the tests, even this one, this is a 2023 one, look at what they what you give you. Give you a sum, okay? And you see it's a sum. He won't give you the product, which is the last one. It's nice and complex, but which although it's doable, It's double. But it's you still just be multiplying the different parts. But if you see here, he will give you the sum. It's the sum. So you'll still be just taking class. I don't want to hear any problem here. You'll be just taking from here and you'll be applying. Let me do it, or let me go apply it in the next video so I don't waste time. Okay, this is 15 minutes. It's enough.